Alright guys, welcome to our channel. If you are new, please subscribe for more tutorial video like this one. So right now we're going to talk about indefinite integration or basic indefinite integration under, of course, integral calculus. So just a quick discussion. Integral calculus is basically the opposite of differentiation or differential calculus or derivatives. So when you saw this symbol, this basically pertains to indefinite integration, and when you saw this kind of symbol which has limit, let's say it has -1, and then let's say the upper limit is 1, this pertains to definite integration. However, in this video we're going to focus only in definite integration, and we're going to create some video for this one to understand that. So let's go to the form of indefinite integration. So the form of indefinite integration will look like this. We have the integral symbol, and we have the function f of x, and then the differential dx that is equal to the antiderivative f of x and then the constant c. So this is the symbol or the indefinite integration symbol. This is the integrand. This is the integrand, and this one is the differential, and all of these are the antiderivative, and c right here is the constant. So we're going to explain that later in this video, why we put plus c right here in terms of indefinite integration. So that would be the form. So let's go to the basic integration rule. So basically there are four important basic integration rule for this one. So the first is the constant rule. So it look like this. So we have the integration symbol, and then we're going to have some constant k. Let's put constant k, and then the differential dx. So that is just equal to, we are going to have k, and then the variable for this one would be whatever variable for this one in terms of so the variable for this one is what would be the variable of the differential. So in this, so since this is in terms of dx, so the variable of course will be x. So if this is dy, so the variable is y, and then of course always put plus c is the constant c. So this is the first rule, which is the constant rule. So let's go to rule number 2. Rule number 2 is the constant multiple rule. So these are the function that has whole number or constant number that is being multiplied by it, and then the function, and of course the differential, which is the dx. So that's just equal to, so we are going to first factor out the constant, that would be k, and then evaluate the integration of the function f of x and then dx. So this one right here is just equal to what we have right here. If we try to evaluate that, we were going to have the antiderivative. So this is the constant multiple rule. Let's put constant multiple rule. And then let's go to number 3, rule number 3. So rule number 3 talks about the sum or difference rule. So we have, if we have a function that is being separated by addition or subtraction or a term, that would look like this. We have the first function or the first term. It could be a function or a term, and then plus minus the second function or a term gx, and then all of that are multiplied to the differential dx. So how do we evaluate this one? In terms of evaluating this integration or indefinite integration, we are going to evaluate each of the term differently or separately. So first thing is that we need to evaluate the first function or the first term. That would be the integration of the first function, f of x, and then do not forget the differential, and then separated by plus or minus, and then we're going to integrate the second function g of x dx. So the integration of the first term or the first function, that is what we have here, is going to be also look like this, just like in rule number 2, and then this one is also look like this but has different symbol, but they are basically the same. The rule number 3 is what we call as the sum or difference rule. That is difference rule. So we do have 3 rules. The last one is my favorite, which is the power rule. So it will look like this. We have the integration or indefinite integration symbol, and then we say if we have a x right here, and then that is or that has an exponent n, and then of course the differential dx. So how do we able to evaluate this one? That would be as simple as it looks. That would be copy the x, and then the n also. However, we need to add plus 1 right here. That would be the numerator, and our denominator would be the new exponent, and then we have to plus 1, and of course plus c. So this would be the power rule. So why put plus c? So for example, if we have the integration of x dx, so evaluating this one, we can use the fourth rule. That would be x, since we have imaginary number 1 right here, just add that. That would be x squared over 2, and then plus c. So therefore the answer would be like this one, and then plus c. And then if we try to derive this one, let's say we have d over dx of x squared over 2, and then plus some constant c. That would be basically equal to this one. So if we try to derive this one, we have to bring down that 2. Leaving behind, we have to cancel this one, and then minus 1. That we just equal to x, and then the derivative of some constant is 0. So that would be x, so equal to what we have a function right here. So why put plus c? Because whenever we try to derive a constant that is in a derivative rule, deriving constant is just equal to 0. Okay, so since we already have the 4 important rule for the basic indefinite integration, let's now go to the example to understand the topic even more clearly. So these are the 4 examples right here, and right now we are going to evaluate the problem that is using the basic integration rule that we have being discussed lately. So let's go and evaluate the problem. So since this is integration of 10x dx, so since we have a whole number right here, we just need to factor that out. We have 10 and integration of x and dx. So how do we evaluate this one? So since this is x and this has an imaginary number 1 exponent right here, so we can use the power rule. So that is equals to 10. So the power rule talks about the put x right here, and then since this is n and we have the value 1, which is the value of n, we just need to add that 1. So therefore we're going to have 1 plus 1. Our exponent would be 2, and then also the denominator rather would be 2, of course, and then never forget plus c. So therefore simplifying, we are going to have 10 divided by 2 would be 5, and then x squared plus c. So this would be our answer for example number 1. So let's go to example number 2. So we have the integration of 1 over x raised to the power of 6 dx. So whenever you face this kind of problem, just convert this raise this denominator to exponent. So whenever you try to raise this one, the value, the symbol of the exponent will change. So therefore that would become the integration of x minus 6 dx. So the reason why we need to raise this up to the numerator is that this is just easy to evaluate since we can use the power rule. So let's go to answering this one. That would be x. So our n is negative 6. We just need to add that by 1. So negative 6 plus 1 is just negative 5. And then, of course, negative 5 plus c. So this would be our answer for example number 2. So let's go to example number 3. So this is kind of a bit tricky. So whenever you try to evaluate this indefinite integration, let's put integration right here, and then let's put a bracket. So we just need to evaluate the terms separately, so we can also use this form, which is 4x cubed, that is over x squared. Since our denominator is x raised to the power of 2 or x squared, its LCD is x squared also. So plus, this would just equal to 2x squared over x squared, and then minus 1 over x squared, and then the differential, which is dx. So therefore we can now simplify all of these. So that would equal to integration of, since we have 4x cubed divided by x squared, so we can cancel this one, leaving behind only 4x, and then plus 2x squared, and then divided by x squared, we can cancel this one, leaving behind plus 2, and then of course just copy this one, negative 1 over x squared dx. Or I mean, we can just directly use this for that one. So since we have a denominator right here which is in x squared, we can raise this to the numerator. So since we have a positive, that would change to negative. So we are going to have x raised to the power of negative 2, and then the differential dx. So this is now very easy to evaluate. We can now use the other rule. So therefore we are going to have the integration. We need to evaluate the integration of each term separately. So therefore, since we have a whole number 4 right here, we can factor that out, and then put x dx, and then plus. So since this is just a whole number, we can put 2, and then the indefinite integration of just dx. This is an imaginary number 1 right here, and then minus the indefinite integral of x raised to 2 dx. So therefore this is just equal to, for the indefinite integral of x is just like in here, what we have here. So this is imaginary 1 right here, just add that to 1, that would be x squared over 2, and in the other we have plus 2, and then the since this has imaginary 1 right here, so this is equal to the indefinite integration of the constant or the constant rules. Therefore we are going to have just the integration of 1 dx is just 1x or equal to x. So let's just put x right here, and then negative the integration of, or the indefinite integration of x raised to the power of negative 2. So let's just use a power rule. So let's put x right here, and then since we have n which is negative 2, we just need to add that 1. Therefore this is going to be negative 1 all over negative 1, and then plus c. So always put plus c at the last term of the antiderivative. So simplifying even more further, so when we try to multiply this one to this one, therefore we're going to have 4 divided by 2, we're going to have 2x squared plus 2x, and then this is plus, since we are going to have negative right there, negative right there, that would become positive, and then we can put x raised to the 1, and then plus c, and therefore we can also rewrite this one into 2x plus trying to put this down into the denominator so that we will have no exponent that is being raised to negative. So therefore we are going to have 1 over x plus c. So therefore this would be our final answer for example number 3. Sorry. So let's go to example number 4. So this one is the hardest among the all of the samples. So let's put equal right here. So based on what we already did in example number 3, we can also rewrite this into the indefinite integration of x raised to 4. We could divide it by 2, or rather 2 square root of x, and then put the other way around right there, also divided that by square root of x, and then put the differential dx. So this function is just equal to this function. So therefore we can now evaluate this even more further. We can put equal right here. So the integration of, so since we have x4, x raised to the 4th power, so that will be x to the raised to the 4th power divided by x, or the square root of x. So the square root of x is just equal to x1, or raised to the power of 1/2. So let's put right here, square root of x is just equal to x raised to 1/2. So that would be it. So whenever you have also 3 in the cube root of x, that's just equals to x raised to 1/3, because this has already an imaginary number 2 right here. So because we are talking about square root, and then this has also a imaginary number 1 right here. So this would become our numerator. That is what we have here, and this would become our denominator. So therefore this would be it for this one, and then we're going to have minus 1 over, or that would be x1 over 2 raised to that. So therefore we can basically simplify this one, or we can subtract the exponents. So we have x, so 4, that would be 4 minus 1/2, that would be equal to 7. So the other term, which is what we have here, since we have this is in the denominator, we can raise this to the denominator, to the numerator rather. So therefore we are going to have x raised to the power of negative 1/2, and then put the x right here. So basically if we try to go back right here, x raised to 4 divided by x raised to 1/2, we can copy the variable right here, since we have the same variable, and then we can subtract the exponent, which is 4 minus 1/2. Therefore that's the reason also why we have x raised to 7 over 2 right here. Simplifying, we are going to have equals indefinite integration of x raised to 7 over 2. Let's put dx, because we are going to evaluate each term separately, and then minus indefinite integration of x raised to negative 1/2 dx. And then since we are running out of space, let's just put the solution, or the continuation of the solution right here. So what would be the indefinite integration of x raised to 7 over 2? So this is in the power rule. So let's just add 1 to each exponent. So copy x, and then 7 over 2 plus 1, that would be 9. That's 9 over 2. And then of course the denominator is 9 over 2. And then since this is subtraction, let's put minus right here. And then also in the second term is let's use power rule. So that would be x, and then negative 1/2 plus 1, that would be 1/2. And then the denominator is 1/2 also. And then of course we are going to have plus c right here, since we already integrate or evaluate the integration right here. So simplifying even more further, let's put this denominator into as a whole number. That would be the reciprocal, since it will look like this: x raised to 9 over 2, and then 1. We're going to, since this is in the division form, that will become its reciprocal when we try to multiply it. And then the same also with the term number 2. Let's put x 1/2, that's over 1, and then if we try to put that right here, it will become 2 over 1, and then plus c. So simplifying, that would be we are going to have 2x raised to 9 over 2, that will be all over 9, and then minus 2, which is x and 1/2 plus c. So this would be our final answer for the fourth example. So that is, guys. Thank you for watching. Study well. If you have question, please comment down below and I will answer that right away. Thank you so much and God bless.